Alright, in this video we're going to look at lesson 1.5, day 1, the graphs of sine and cosine. So we're going to let f of x be sine of x and g of x be cosine of x, and then we want to fill in this table below for the two functions and then graph them on the same coordinate grid. Now, you'll notice that we only are using certain values, 0, pi over 2, pi, 3 pi over 2, 2 pi, instead of every single point on the unit circle, and that's going to be for the ease of use. If we look at these are our quadrant angles. Our answers are going to be zeros, ones, and negative ones. We could get a more accurate graph if we used more points, but for the sake of ease, we're going to use just these points here. And I also want to point out, as far as, other than just the quadrant angles, something to point out that is going to help us when we go to graph. If you remember, the period of sine and cosine, so how long it takes to repeat itself, is 2 pi. So once around the unit circle is how long it takes. So you'll notice that we have 0 and 2 pi as our endpoints for one period. If you cut that in half, we're going to get pi. If you cut the distance from 0 to pi in half, we're going to get 2 pi. And if you cut the distance from pi to 2 pi in half, you get 3 pi over 2. So once we start messing around with the period and shifting these things left and right, we're still going to keep that same idea. We're going to find out how long the period is, cut it in half, and then cut each of those halves in half to figure out the 5 points that we're going to want to use on our graph. So if we want to, or what we want to do rather, is fill these in. So sine of 0 is going to be 0, sine of pi over 2 is 1, sine of pi is 0, 3 pi over 2, negative 1, 2 pi is 0. And for cosine, those values are going to be 1, 0, negative 1, 0, and 1. So all we have to do is just plot our points. You'll notice that on our x-axis, we're going by pi's over 4. So that's going to make these things a little bit easier to graph. So our sine function is going to start at 0, 0. Pi over 2 is at 1, pi is at 0, 3 pi over 2 is at negative 1, 2 pi is at 0, and then we're going to make a nice smooth curve as the best we can to connect those. Now, this is just one period. This is going to continue going this way forever, and it's going to continue going this way forever, but the pattern is just going to repeat. So that's the basic look of the sine graph. Now, cosine starts at 1, goes to 0, goes to negative 1, goes to 0, goes to 1. So this one looks like it might be like an absolute value, right? But we still want to make sure it has that curve to it. So it's really just a sine function that we moved. So how we're going to handle that, just make sure you kind of round it off at each maximum and minimum. And that's the basic shape of cosine of x. Now, what we're going to do with those graphs is we're going to move them, shift them left, right, up, down. We're going to stretch them. We're going to change our period. And all of those things are going to be based on the standard forms for sine and cosine. So the standard form for sine is going to be a times sine of bx minus c. And then cosine is going to be the same. It's just a cosine of bx minus c. So the first thing that we're going to change is the amplitude. So the definition here says the amplitude is going to represent half the distance between the maximum and minimum values of the function. So if we look at our parent functions back here, the minimum value of, we'll look at sine, is negative 1. The maximum value is 1, so that distance is 2. The amplitude then is going to be 2. You can kind of think about it as the height of the graph, right? If we start at 0, it's going to go as high as 1, so its amplitude is 1. Same thing with cosine. The amplitude is going to be 1 standard. So to find the amplitude, that's just going to be the absolute value of a. So if we had like a negative sign out front or a negative 4 outside, 4 would be the amplitude. The period, remember, that's how long it takes for the graph to repeat itself. A normal function, just our parent function, has the period of 2 pi. In order to find our period, if we look here, b is going to be changing our period. It's going to be 2 pi divided by b. So if you think about your parent function, it's just x, so sine of x. So the b value would be 1. 2 pi divided by 1 is 2 pi, so that's going to be our period of the original graph. So let's look at a graph and change the period and see what happens. So graph 1 period of 3 sine of x over 2. And I made a mistake when I made this graph for you. If we look over here, this is the value of 1. But looking at our graph, our amplitude, the height of this graph is going to be 3. So when we graph this, we want to look at this as each little mark here being 1. So we got to think about our period. Usually our period is going to go from 0 to 2 pi, but in this case, b is equal to 1/2. So our period is going to be 2 pi divided by 1/2, which is 2 pi times 2, which is 4 pi. So our period is going to go all the way to 4 pi this time. So if we think about what points we need, we're going to start at 0, we're going to end at 4 pi. Halfway between that is going to be 2 pi. Halfway between 0 and 2 pi is pi. Halfway between 2 pi and 4 pi is 3 pi. So these values of x are going to represent the equivalent of 0, pi over 2, pi, 3 pi over 2, and 2 pi. So the y values are going to be the same, except our amplitude now is 3. So we're still going to start at 0. This used to be 1, but our amplitude's 3, so we're going to go to 3. Back to 0. This used to be a -1, but amplitude's 3, so we're going to multiply by 3, get -3, and then back to 0. So we go 0, 0, pi, 3, 2 pi, 0, 3 pi, -3, 4 pi, 0. So the amplitude, we're just going to multiply those y values that we originally had by our amplitude. And then the period is just going to stretch it out. And again, we want to just find the starting point, the ending point, cut it in half, cut it in half, cut this distance in half, and that's how we know where this thing's going to go. So that's amplitude and period. We can also have horizontal and vertical shifts. The horizontal shifts are going to work the same way as in the past. So if you had something like 2x minus 3 inside your parentheses, we would go to the right 3. And with our period, we can actually come up with a set of equations that's going to make this a little bit easier to deal with. So whenever we want to find the starting point, we just have to solve the equation bx minus c equals 0. And the ending point is going to be bx minus c equals 2 pi. So the 0 and the 2 pi is our original period. When we go to solve, we're going to have to divide by b. So 2 pi over b, that's where our period is going to come into play. And then our shift of c is going to come into play. It's going to solve it for us. So we don't really have to think too much about this one. So let's look at an example of that. Kind of show you what I mean. So graph 1 period of 1/2 sine of x minus 3. So in this case, bx minus c is the same thing as x minus pi over 3. So to find our starting point, because we have shifted to the right a little bit, we want to solve x minus pi over 3 equals 0, and to find our ending point, we want to do x minus pi over 3 equals 2 pi. So to solve these, we're going to get x equals pi over 3, and then x equals 7 pi over 3. So halfway between pi over 3 and 7 pi over 3, so pi and 7 pi is 8 pi divided by 2 is going to be 4 pi over 3. Halfway between pi and 4 pi over 3 is going to be 5 pi over 6. And then over here, we're going to get 11 pi over 6. So originally it would be 0, 1, 0, -1, 0, but our amplitude's 1/2, so we're going to say 0, 1/2, 0, -1/2, 0 for our points. So starting at pi over 3, we're going to get 0. At 4 pi over 3, we're going to be at 0. 5 pi over 6 is going to be right here. That's going to go up to 1/2. we're back to 0 at 7 pi over 3. And then halfway between there at 11 pi over 6, we're at negative 1/2. So one period of this function is going to look like this. And then obviously it's going to keep going on following this pattern forever in each direction. So that's how we're going to find our starting point and our ending point. We're going to use those two equations. And then again, we're going to split the range in half, split each little half in half, and that's where we're going to find our points for this. So the last thing we need to talk about is going to be our vertical shift. And again, it's going to work the same way. A +2 outside like this is going to move our graph up. If it were -2 outside, we'd move our graph down. So let's think about where we start and where we end this graph. We want to start the graph at 2x equals 0, so divide by 2, x equals 0. We want to end at 2x equals 2 pi, so x equals pi. That's our period, right? So if we thought about our period as 2 pi over b, b is 2, 2 pi over 2 is just pi, so there's our period right there. So 0 to pi, cut that in half, we get pi over 2, cut that in half, we get pi over 4, cut this distance in half, we get 3 pi over 4. And here's where we kind of have to think a little bit. Cosine originally goes 1, 0, -1, 0, 1. Multiplying it, our amplitude by 3 is going to make it 3, 0, -3, 0, 3. And then we have to shift everything up 2. So now we're going to get 5, 2, -1, 2, 5. So those are the points we want to graph. 0, 5, pi over 4, 2. I'm sorry, yeah, pi over 2, -1. 3 pi over 4, 2. And then pi 5. And then we just connect them, and that's our graph. And again, this is going to continue going forever in each direction. So that's the basics of graphing sines and cosines. That'll do it for this video. We'll see you in the next one.